All right. So organic chemistry is all about carbon and hydrogen. I mean, organic chemistry is the study of hydrocarbon. We have two types of compounds, the hydrocarbon and you can say hydrocarbon and the organic compounds. So basically, hydrocarbons, hydrocarbons are those compounds which contain hydrogen and carbon only. But then what is organic compound? Organic compound are those compound which contain one more element other than carbon and hydrogen. For example, the glucose, you can say CHO compound, the glucose. If you remember the formula of the glucose, that is C6H12O6. So this is not hydrocarbon because you can see oxygen here. So this is not hydrocarbon, this is organic compound. So this is the main difference between organic compound and the hydrocarbon. Hydrocarbon contain hydrogen and carbon only, and organic compounds, they do have some other element along with carbon and hydrogen. So basically alkane and alkenes, I mean, these two are the classification of hydrocarbon. And for organic compounds, we have polymers like we have polyester or we have ester, aldehyde, ketone, alcohol, carboxylic acid. They are organic compounds. Okay, so let's start from the hydrocarbon. Let's start from, you can say alkane or alkene. So what are hydrocarbons? Hydrocarbons are those compounds which contain carbon and hydrogen only. There will not be any other compound. There could be number of carbon, there could be a number of hydrogen. That's not a big deal. So hydrocarbons are those compounds which contain hydrogen and carbon only. For example, I'll give you the example, but before the example, let me tell you, hydrocarbons may have a chain structure because I just told you that they contain carbon and hydrogen only. There could be number of carbon in any hydrocarbon, and definitely every carbon would be making bonds with the hydrogen. These black bonds are filled with hydrogen, you can say. Okay, so let's just start. Hydrocarbon is basically divided into two portions. I mean, there is a classification of hydrocarbon. We have in our syllabus we are discussing alkane and alkenes only, but you know very well there is one more which is alkyne, the triple bond between two carbon, which is not included. Okay, so first of all, we have carbon-carbon single bonding, alkane. And other than alkane, we have one more, which is alkene. What is the difference between alkane? In alkane, carbon is making single bond with another carbon, or you can say carbon is joining another carbon with a single bond. This is alkane. And in alkene, definitely carbon would be making double bond with another carbon. This is alkene. Keep in your mind, if the whole chain like this one, let me show you here. I just, this one, just check this one. The whole carbon chain has single bond. So that is alkene. If you can see any one double bond, for example, there is double bond between these two carbon, the whole chain is alkene. Otherwise, this is alkane. Sorry, I guess I have used the wrong word initially. I mean, if there is no double bond, for example, like this, if there is no double bond, so this is alkane chain. This, you can see all the carbons are making single bond with another carbon. We have to check the carbon bonding. So, and carbon is the main element of the organic chemistry. So whenever you are working in organic chemistry, you have to focus on carbon, that how carbon is making bond with another carbon and how carbon is making bond with oxygen or carbon. Then you can decide the name of the chain. You know, we do have alcohols and we have different types of alcohol, the primary alcohol, secondary alcohol, tertiary alcohol, and all are the basis of carbon. So carbon is the central element. So whenever you are working in organic chemistry, definitely you have to focus on the carbon. Okay, so back to the topic. If there is no any double bond in a chain, so you can say that this chain is alkane chain. But if you can see any one double bond, for example, there is a double bond between these two carbons, so this is alkene. There could be more than one double bond. It depends. There could be more than one double bond, but this is still alkene. So simple. If any carbon chain or if any hydrocarbon chain, if you can see any one double bond. So the chain will convert from alkane to alkene. Okay. Now let's focus on alkane. What are alkane? Because we have to start from the basics. So we are going to start from the alkane. Alkane are the simplest hydrocarbon, you can say. Okay. Alkenes are also simplest. Actually, hydrocarbon are simplest. And they are very simplest as compared to organic compounds. They are something like complex and they are more difficult. Their reactions are more difficult. So we are going to start from alkane. Alkane is actually hydrocarbon, if you know. Alkane means carbon is making single bond with another carbon. Oh, wait, where I am? Yes. Carbon is making single bond with another carbon. This is the alkane. The next thing which you should know is we have different type of alkane. I mean, on the basis of number of carbon, we have different type of alkane. I just told you that alkane have a chain structure. The chain could be shortest. I mean, it could be shortest that it is consist of one carbon only, and the chain could be little longer, like it has three carbon, and the alkane chain could be made up of alkane chain can be made up of more carbon, more than 6 carbon, you can say more than 10 carbon, but all the carbon should join single bond. I mean, all the carbon should join another carbon with a single bond, means there should be single bond between every carbon. Then you can say that this chain is called alkane chain. So on the basis of number of carbon, we have different names of the alkane. For example, if you have, for example, yes, for example, if you have a structure which contain one carbon, see, this is single carbon. You know, there are two methods by which you can work on the alkane. Number one is direct, you can directly fill some bonds with the hydrogen. Otherwise, we do have one more thing, which is called formula of the alkane or alkene. I'm not moving toward the formula right now because I'm trying to make topic more easy for you. So let's forget about the formula for some time. For example, this is one carbon and there is no any other carbon. Basically, if you want to say that this carbon is alkane or alkene, so you have to check the bond between two carbon. There is only one carbon. So we just added, or we just put this structure into alkane. This is the simplest alkane actually. For alkane or for alkene, we have to check the bonding between two carbons. That two carbons are joining each other with a single bond, or two carbons are joining each other with a double bond. That's what we have to check. But here we have only one carbon, so we just put this structure into the alkane, you can say, and the name of alkane is methane. This is the simplest alkane, and the name is methane. You already know from O levels, I guess. So this is methane. Okay, let's move to another. For example, if there are two carbon in a chain, so that is called ethane. 3 carbon in a chain, you have to learn these names. 3 carbon in a chain, so the structure is called, after ethane, there is propane. Keep in your mind that you have to fill the rest of the bonds with the hydrogen to find out the formula. There is a general formula of alkane and alkene also. But if you forget anything in the general formula of alkane and alkene, so definitely you will get the wrong answer. So I'm not moving toward the formula right now. So let's try to make the topic much easy. See, if there are 2 carbon in a chain, so what will be the formula? For example, I just said this is ethane. So, you know, carbon always make 4 bonds with another carbon. Every carbon make 4 bonds with another carbon. So, I mean, 3 bonds of each carbon are still free. I mean, there are 3, definitely there are 3 unpaired electron of carbon. One here, and one here, and the one is making bond with another electron of the carbon. They are sharing one electron, but there are 3 unpaired electron which can be paired with other electron of the same element or of the other element. So you can bring 3 hydrogen here. You can bring 3 hydrogen here. See, what is the formula of ethane now? I mean, you should know ethane means two carbon. Ethane, alkane. Ethene will be alkene. So ethane, alkane means there will be two carbons. So you just have to draw two carbon and you have to fill rest of the bond with the hydrogen. You can easily find the formula by doing this whole stuff. And you can see this is the formula which I'm getting is C2. C2, and how many hydrogen are there? 1, 2, 3, 4, 5, 6. So C2H6 is the formula of ethane. Okay. Then what is the journal formula? Because I mean, this method is easy to find the formula of the ethane. I mean, you should know that ethane means two carbon and both the carbon are joined with a single bond. That's what you should know. But what is the journal formula of the ethane? Sorry, what is the journal formula of the alkane? CN H 2N plus 2. This is the journal formula of alkane. By the help of this formula, you can easily find the formula of ethane, propane, hexane, any alkane you have. But you know, this one is the easiest method because if I'm asking you what is the formula of propane, so you should know how many carbons are there. So you can write those three carbon on the paper and then you can fill rest of the bond of the carbon with the hydrogen. You can easily find the formula of the propane. But if you say no, miss, formula is more easy. So you can see this is the formula. What does the N means? N means number of carbon. Means if I'm saying that what is the formula of ethane, and if you want to find formula through this journal formula of the alkane, so you should know the number of carbon. So it's better. I mean, isn't it better to use this method, the first method? But let me show you that how to work according to the formula. See, we are working for ethane now. I'm going to find the formula of the ethane. Here I use the structure thing, but now I'm using the formula. So N means number of carbons. So if I'm saying that I need to find the formula of ethane, so I should know that how many carbons are there in ethane. Otherwise, I cannot use formula. N means number of carbon. So okay, so I need formula of ethane. So N means number of carbon. So ethane has two carbon. That's what we should know. Okay. H, there is 2N, 2. And what is N? Number of carbon. N means number of carbon. In whole formula, N means number of carbon. So how many carbons are there? 2 plus 2. You can see I'm getting C2 and H. 2 multiplied by 2 will give you 4, plus 2 will give you 6. So C2H6 is the formula of ethane, which we get like this. Structure thing is more easy. Reason, let me tell you the reason. I mean, you have to learn the formula. They can ask you in MCQ, you can say. But, you know, formula is little tricky. Sometime you may forget about this plus 2. There is a possibility. I mean, there are chances of mistake. So this method is more easy to find the formula of any alkane, because if you are using the structure thing, or if you're using the general formula of the alkane, to find the formula of any alkane, you should know number of carbon. Are you getting my point?
Yes.
Okay, let's move now. What we have? Okay, so we just discussed that 2 carbon means ethane. That will be your homework, and you have to submit that homework to me by tomorrow or tonight. And the homework will be you have to find the formula of every alkane by both method, by using formula and by doing a structured method also. Then you can easily find out which one is easy. So if there is 1 carbon, so you can call it methane. Actually, methane is totally different type of compound, and there is no any carbon with which we could check the single bonding or the double bonding of the carbon, so that we could discuss if it is alkane or alkene. So we just put CH4 compound in the list of alkane, and that is methane. Okay, let's move. The next one. If carbon is making single bond with another carbon, means there are 2 carbon, and definitely rest of the bonds will be filled by hydrogen. That's what you should know. I'm not going to give you any formula now, because now you know how to make formula, and that will be your homework. Oh, yes. Now, see. So if there are 2 carbon, ethane. If there are 3 carbon in a chain, propane. A-N-E. Keep in your mind, you have to write ane in the last. Okay, because we are working for alkane right now. We are working for alkane. These are not alkene, these are alkane, the single bond. Okay, next, if there are 4 carbon, rest of the bond you have to fill with the hydrogen, and the name will be, after propane, we have 1, 2, 3, 4, butane. 5 carbon, but all should join with the single bond, 1, 2, 3, 4, 5. 5 carbon means pentane. What else you should know? Yes, you should know about the 6 carbon also. 4, 5, 6. Hexane. Hexane is most common. Hexane and the butane and the propane. No, I mean, ethane is more common actually. That is the easiest or the simplest hydrocarbon. But if they will give you some complex questions, so they are going to give you propane or butane or hexane or octane. So actually, hexane and butane. I have seen a lot of time hexane and butane in your past paper. Wait. Yes. So 1, 2, 3, 4, 5, 6. Okay, hexane. Now 7 carbon, 3, 4, 5, 6, 7. 7 carbon means heptane. Not heptene. That will be hexene. Sorry, that will be alkene. Okay, the last one, or you can say the second last, 4, 5, 6, 7, 8. 8 carbons are there. So this is called octane. You should know about the 9th carbon also. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is called nonane. That's it. The 10th carbon means decane. The 20 carbons, dodecane. You don't have to learn that much. That's enough. I guess you should know about hexane, butane, and octane in detail. So these are alkanes. You can see every carbon is joining another carbon with a single bond. If I ask you that what is the form, these are alkane, hydrocarbon, because there is only carbon which is joining another carbon with a single bond, and rest of the bond of the carbon will be filled by hydrogen. So for example, if I ask you, okay, if I ask you that what is the formula of octane, so definitely you should know that octane means 8 carbon. Otherwise, you cannot give me the formula. Okay, now you have two options. Either go for a general formula of the alkane, which I just told you, alkane. C2, oh, sorry, CN, H2N plus 2. Okay, this is the general formula of the alkane. All right. So what I'm asking you, I'm just asking you the exact formula of the octane, that what is the formula of octane. So definitely, if I'm asking you that what is the formula of the octane, so you should know that octane means 8 carbon in a chain. So you can say C8H2N. So 2 and N means number of carbon, again 8 plus 2. So you will get the formula which is equal to C8H. 2 multiplied by 8 will give you 16, and plus 2, 17, 18. This is the formula of octane. If you know this, I mean, if you know the general formula of the alkane, you can easily find the formula of octane in a minute, but there could be chances of mistake. So the other option is, I mean, we can do any mistake in calculation. No? So we have one more method. I mean, we should know that how many carbons are there in octane. So what you can do, you can fill all rest of the bond which are empty, the unpaired electron with the hydrogen. See, I'm working here. 1, 2, 3 hydrogen, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. See, I'm getting the same thing. So it's totally up to you. In exam, if you forget the formula of octane, if you forget the formula, general formula of alkane, you have another option, this one. Is it clear to you now?
Yes.
Okay. So let's move to, wait. Yes. Okay. Let me tell you one thing here. The thing which we just discussed is all about alkane. The next thing which you should know in a basic is alkene. Alkene means, let me write it here, carbon-carbon double bond. There could be one double bond. There could be multiple double bonds. It depends. After that, I'll tell you about the pi bonding of carbon also. All right. So see, there is no any methane in alkene family. There is no any methane-like a structure. In methane, there is only one carbon. We are already unable to find carbon-carbon single bonding in methane. So how can I show you carbon-carbon double bonding in methane? So there is no alkene of methane. Okay. So it means we have to start from ethane thing. Okay. So if there are two carbon and they are joined with a single bond, so definitely you can call it ethane. Single bond, ethane. But if you can see double bond between those two carbons, so you can call it ethene. Now this is ethene. Let me change color from here so that you should know. See, ethene. It is not ethane. Carbon single bond and one double bond. See, there are three carbon and you can see one double bond. That is propene. If you can learn all the alkane, I mean, if you can learn all the detail of alkane, means if there are two carbon, so what will be the name of the chain? So you can easily work for the alkene. I mean, this will be very easy for you to learn alkene also. There is only one difference on the double bond, and instead of ane, you have to use word ene. This is propene. For example, if there are four carbon, there could be double bond anywhere between any carbon, you can say. See, where I have made double bond. 1, 2, 3, 4, butene. For example, there are 5 carbon, 1, 2, double bond, 1 carbon, single, and 1 more double bond. There could be 2 double bond. This is pentene. Actually, the name will be little changed when we were, after that, we are going to discuss the name of the organic, we have to discuss IUPAC system, that how to give name to your hydrocarbon chain or to your organic compound. So at that time, we have to discuss that if there are, wait, let me show you, if there are 2 double bond in pentane, or if there is only 1 double bond in pentane. So what will be the difference here? We have to discuss after that. Okay, so I have written wrong spelling over here. This is pentane. Okay, there is spelling mistake in pentane. You can correct it yourself. Okay, let's move without wasting time. So simple is that if there are 6 carbon in a chain, that is called hexane. But if you can see any double bond in a hexane chain, so it will become hexene. If there is any double bond between heptane chain, it is heptene. There could be more than 1 double bond. There could be 3 double bond. I told you there could be multiple double bonds. Same with octane. If there are 8 carbon in a chain and all carbon are joining other carbon with a single bond, you can call it octane. Octane. But if you can see any double bond in octane chain, that is octane. So this is so simple. This is all about alkane and alkene. This is the basic of organic chemistry. Other than this, the main thing which you should know in organic chemistry is the structures, the formulation of organic compounds, or the structures of hydrocarbons. So, for example, okay, see, 1 carbon, 2nd carbon, 3rd carbon, 4th carbon. Okay, you can fill rest of the bond with hydrogen. Can you tell me the name of this chain? What could be the name of this chain?
Butane.
Okay, so this is butane because there is no any double bond. Okay, so in organic chemistry, you have a lot of options. For example, you can show your butane compound like this, and you have one more option. You can do like this. Butane is C4 and H10 now. Wait. C4H10, let me write like this so that you could see clearly. C4H10, this is butane. And We have one more option. That is simplest ratio. We can work on the simplest ratio also. C, H. What will be the simplest ratio? I'm going to do something like empirical formula. So 4 is to 10. You can use the table of 2. So 2 multiplied by 2, 4, and 2 multiplied by 5 will give you 10. So C2H5. This is also butane, but this is not the actual formula of the butane. Okay, so let me tell you one thing, that this one is called the simplest ratio, which you already know that this is empirical formula. Empirical formula is not the original formula of the compound. And just by looking at empirical formula, you will never know that what is the compound. Just by looking at empirical formula, you cannot find that what is the compound, which compound is this. You can see. This is empirical formula. So empirical formula is not the real formula. We need empirical formula just to check the simplest ratio of the elements in a compound. For example, if I ask you that, Zainab, I need to make a butane, for example. So you will say, Miss, you have to bring 4 carbon and 10 hydrogen. No, I need the simplest ratio. So you can tell me, Miss, for every 2 carbon, you need 5 hydrogen. This is the simplest ratio. I can multiply this ratio with 10, 20, 30. It depends on how much butane I do need. So empirical formula is not useless. We need empirical formula to check the ratio of the elements in the compound, that how that compound is made up of. For example, let me show you. We need empirical formula, especially for these type of compound. I'm moving toward physical chemistry again. See, H2O and one more, H2O2. You can see this is hydrogen peroxide and this is water. For the water, we have the same empirical formula, H2O. For the hydrogen peroxide, HO is the empirical formula. You can see this is the importance of empirical formula, that empirical formula can tell you about the simplest ratio of the elements in a compound. I mean, if you're going to make hydrogen peroxide, so you have to take equal amount of hydrogen and oxygen. And if you want to make water, so you can see that hydrogen is used double as compared to the oxygen. This is the importance of empirical formula. So for the butane, we have different options. Either we can give the empirical formula of the butane sometime when needed, but other than this, when you have to write the butane on the paper, so one option is you can write butane butane, but organic chemistry is all about you can say structures. So you can express or you can write your butane like this. This is called the molecular formula of the butane. Molecular formula of the butane means the original formula. Then what is this? Yes. What is this? Students usually say, Miss, this is the structural formula. If that is empirical formula, another one is molecular formula. This is the structural formula. Okay. But in A levels, this is not a structural formula because we have one more option to express butane. Let me show you. See, I can do like this. Let me change color for you so that let me select lightest color. Okay, see, you can pick this portion and then 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 you can write the formula. See, you can say, Miss, there is CH3, then there is CH2. You can see I have I have already broken the whole structure into 4 portions. CH3, CH2, again CH2, and then again CH3 in the last. What is this? If you say, Miss, wait, let me write. Yes, if you say that, Miss, this one is the structural formula. This is not the structural formula because according to the A levels chemistry, this one is a structural formula. This one is a structural formula. Yes, this one is structural formula because this formula is telling you about the structure. What is formula? I mean, there's a difference between the structure and the formula. This actually, this is the formula, because this formula is telling you about the detail of a structure, that how carbon is joined in a structure, or how carbon is showing in the structure. So this is the structural formula. Just by looking at a structural formula, you can easily find that, okay, one carbon is joining with 3 hydrogen, and the second carbon in a butane is joining with 2 hydrogen. The third carbon is also joining with 2 hydrogen, and the last carbon means the fourth carbon has 3 hydrogen around it. So this is the structural formula, which is giving you the detail of a structure. Then what about this one? If this is the structural formula, so what is this one? Now this is the confusion now. Okay, this is also a formula, definitely. In organic chemistry, this is also the formula, but which type of formula is this? Because I have already told you that what is a structural formula, which is giving you the structure, which is giving you the detail of a structure. So what about the above one, in which all you can see all the bonds, that carbon is making single bond with hydrogen, and carbon is making single bond with another carbon. This is called displayed formula. This is called displayed formula. In exam, it depends. Sometimes they ask you to give a structural formula of a compound, and sometimes they will ask you to give the displayed formula of the compound. So you should know what is the difference between these two. Mostly they are asking you for the structural formula, and whenever they ask that give the structural formula of this thing and that thing, a student usually make this thing like, no, this is not the structural formula. This is the displayed formula, is in which everything is displaying correctly. Exactly, in detail, whatever you say. We have one more formula: empirical formula, molecular formula, displayed formula, and a structural formula. I just told you that A-level chemistry is more focusing on a structural formula. You should know about this stuff for every compound. But you can see your past paper. In A-level chemistry, we have one more type of formula, and that is called a skeletal formula. What is a skeleton? Skeleton, I mean, if if I ask about a skeleton from the bios, what is skeleton? Which is made up of bones only. If there is double bones, you can show you can show in your skeleton a diagram that there are double bones in your arms or in your legs, lower legs. Otherwise, there are single bone, and in rib cage there are multiple bones. So all the bones can be shown in the skeletal formula. Bones are just like the bonds. You have to show every bond in a skeletal formula. But there, we never show heart or lungs or the soft organs in a skeleton. You don't have to show any other carbon, or I mean, carbon is just like your muscles. You don't have to show carbon. You have to show bones only, means bonding. You don't have to show any carbon. You don't have to show any hydrogen in skeletal formula. But yes, you have to show any double bond if present in a chain. You have to show a functional group also. Functional group, let me make this topic more easy for you. I just told you, in a skeletal formula, you have to show all the bonds. Bonds are just like the bones. I mean, a skeleton is made up of bones now. You have to show all the multiple bones. Like in ribcage, there are multiple bones, so you have to show all the bones in your skeleton. The skeletal formula, you have to show all the bonds, single, double, or triple, whatever present in a chain, but you don't have to show any carbon and hydrogen. But you have to show a functional group. How would you remember this? Your skeleton, I mean, if there is any fracture in the bone, you have to show that fracture in the skeleton, that the bone is broken from here. So F for fracture, F for functional group. That's how you can learn this, or that's how you can memorize it. You have to show the functional group, means you have to show the fracture. Now see, there is no any functional group. What is functional group? The double bond is also called functional group sometimes, but we have alcohol, the carboxylic acid, OH, COOH, NO2, NH3. There is nothing like that. This is hydrocarbon. It means no functional group is present. But yes, carbon and hydrogen. So how you have to show skeletal formula? See, there are 4 carbon now. Now see, this is the skeletal formula of the butane. This is the skeletal formula of the butane. How would I know? Wait, I mean, how would I know that this is butane? These corners are showing carbon. 1 carbon, second carbon, third carbon, and fourth carbon. And you can see hydrogen is just like hemoglobin. Where is hemoglobin? In the blood. We never show blood in the skeleton. So you don't have to show any single hydrogen. If the hydrogen is connected with functional group or something, then we are going to show in a skeletal formula, but we don't have to show any hydrogen here. So the skeletal formula of the butane is just this. Just you don't have to show this dot or something. No, this is the skeletal formula of the butane. Is it clear to you?
Yes, it's clear.
Let me show you one more example. For example, you have 1 carbon, 2 carbon, 3 carbon, 4 carbon, and there is double bond. Now I'm not going to show any hydrogen. Now see, 1 carbon, 2, 3, 4. This is butane. But you can see there is double bond between these 2 carbon. This is